have this, the first thing is to split it into different components. We have AgL, NH3, NH32. Remember, chlorine is minus, right? So if chlorine is minus, definitely this will be what? Plus. And we can now see that our coordination sphere now is what? Positive. Are we together?
Yes, sir.
So here now we have seen the coordination sphere to be positive. We cannot calculate the oxidation state of silver. So we have silver plus ammonia is 0. The oxidation state of any free compound is what? 0. So how many ammonia do we have here? 2. And everything will be equal to the charge. So we have silver plus 0 is equal to plus 1. So silver is now equal to. Now we have gotten the oxidation state of silver. We have gotten the oxidation state of what? Silver. We can now name this compound. So the compound is going to be named. We start with the ligand. This one, is it a monodentate or bidentate ligand? Monodentate ligand. So this is going to be diamine silver 1 chloride. Out together? Diamine silver 1 chloride. So we are done with this. We now come back to this. We all know potassium is plus. Are we together?
Yes,
and how many potassium do we have here? 4. So this is going to be NiCN2OX2. Then this will be 4 minus. 4 what?
Minus.
Because of the 4 here. Are we together? We know this is plus. So this is going to be 4 minus. So here, the coordination sphere here is what? Negative. That means the transition method is going to end with what? ATE. So we need to find the oxidation state of nickel here. Nickel plus cyano is minus 1. And how many do you have here? 2. Plus, this is ethane 1,2-dioic acid. The oxidation state is minus 2. And how many do you have here? Then everything will be equal to minus 4. So this is going to be nickel minus 2 minus 4, everything equal to minus 4. So nickel is going to be equal to minus 4. When this one crosses the equality sign, it becomes what? Plus. So we have nickel is now going to be equal to plus 2. So the oxidation state of nickel now is what? Plus 2. Now we can now name. Remember, this is negative. So the name is going to be potassium. Right? We have 2 ligands. We have the oxalato and we have the cyano. Oxalato and cyano. So we are going to name them in alphabetical order. So we have cyano, and cyano is a monodentate ligand. So it's going to be diamine, right? Then we now move to oxalato.
No,
Dicyano, sorry. Dicyano, right? Dicyano. Then we now move to oxalato. But remember, oxalato is what? A bidentate ligand. So when you have 2, you call it what? D. Oxalato. Oxalato. Then we continue with what? The transition method. So since the coordination sphere is negative, this is going to be nickelate what? What's the oxidation state? 2. Right? 2. Then for this number 13, we have sodium to the plus. And how many sodium do you have there? 4. So this is going to be FeCN5 SNO, then 4 minus. Are we together? So we need to calculate the oxidation state of iron. So this iron plus cyano is minus 1 times 5 plus This is sulfur, right? So it's going to be -2 plus NO is a neutral compound. The oxidation state of any neutral compound is what? 0. Everything equal to -2. So we have iron -5 -2 is equal to what? -4. So iron is now equal to -4 plus 5 plus 2. So iron is now equal to plus 3. Are we all together? We are all together. Now we can now name this, right? So this one, the coordination sphere is negative. Iron is not going to be named iron, it is going to be ferrous. It's going to be ferrous because the coordination sphere is negative. Are we together? The coordination sphere is what? Negative. How many ligands do we have here? 1, 2, 3. And all of them are examples of monodentate. This is cyano, sulfido, nitrosyls. Right?
Yes, sir.
So here, nitro, sulfido, cyano, we have to name them in alphabetical order. So the name is going to be sodium, pentacyano, right? Pentacyano. Then we have nitrosyl. Then we have sulfido. Then what? Ferrite. Ferrite what? Ferrite. So this is the name.